So last week, 7.2, we multiplied radicals together and divided them. This time we're like more adding and subtracting. So that's cool. What are... All right, so you said same variable to the same exponent would be like terms. Okay, so you can write that down just so you remember. Same variable to same power is what I usually say. So like radicals, in order to add radicals, they have to be very similar. But it's not necessarily the same variable to the same power. They have to have the same index. Okay, so that's a little number up top. And they have to have the same radicand, which is whatever's inside the radical. So we will add and subtract these using the distributive property. Now you don't have to write it out the long way every time, but I'm going to the first time just to make sure we understand how it works. Okay, so here, two terms. Do they have the same index? Yes. Yes. Do they have the same radicand? Yes. Yes. So the process that makes this work is the distributive property that we can bring a cubed root of x out to the front. So we took it out of this and we took it out of this, which leaves us with 5 minus 3. So what would your answer be? 2 cubed root of x. So the distributive property is what makes this work, but I'm thinking you could have probably just said, oh, look, it's 5 minus 3. That gives us 2, right? Okay. So you don't have to write out the distributive part every time. I just wanted you to see it. Okay, for B, do they have the same index? Do they have the same radicand? No. So we cannot combine. And we're done with that one.
Oh, I like that.
Okay, next one, same index. Yes, same radicand. Yes, subtract them. What do you get? 4th root of xy. Starting out easy enough, right?
It's going to be one of those things where it's like, oh,
Okay, so the next one's to simplify. Let's go ahead and simplify each individual term as much as we can and then see if we can add or subtract any. Because right now, we can't add or subtract any. The radicands are all different. Okay, so 18 breaks down into 9 and 2, 3 and 3. So when a 3 comes out, what do you get there? You get 18 square root of 2 because you multiplied 6 by 3. Okay, now let's break down the 8. 4 and 2, 2, 2 and 2. You get 8 square root of 2 when you multiplied 4 by the 2. Okay. Let's see, 8 and 4, 2 and 4. I can go ahead and circle my 4s. So minus 12 square root of 2. When you multiplied 4 times 3, you get 12, and then your 2 is left over. Okay, now, do they have the same index? Same radicand? Yes, so we can add them all together. Okay, so 18 plus 8 is 26. Minus 12 equals 14 square root of 2. Still okay? All right. Now we're gonna combine multiplying and adding because we are gonna multiply our binomial radical expressions by using what method? FOIL. Okay. So first times first gives us 6. Okay. Last, or outside times outside. 12 square root of 5. Remember, numbers outside radical multiply together, numbers inside radical multiply together. Okay, now inside times inside. 4 square root of 5. Okay, and last times last. 8 squared to 25. Okay, so that's really 5. All right, I'm going to simplify a little bit. I get 6 plus 16 square root of 5, right? We had like radicals. Plus 40, and then we get 46 plus 16 square root of 5. Is that what y'all got? Yeah.
Is that it?
Mm-hmm. You still good?
But you don't add the 16 and the 46.
No, because they are not like radicals, because this one does not have the square root of 5.
Okay.
All right, so we have worked with conjugates already. When was that? At the end of last chapter, I think. So conjugates are expressions that differ only in the what of the second term. Anybody remember? Like this. These two are conjugates, so what differs? The sign of the second term. It's like A plus B and A minus B, sort of a thing.
Oh, was this one where it gave us like the square root of green?
Yeah. Yeah, so we did this with square roots and imaginary numbers, but right now we're not working with imaginary numbers, so don't worry about that. Okay, so we're going to work out these 2 problems right here, and that'll kind of give us a skeleton to follow all the rest of the time, which means shortcut. Okay, so let's FOIL the one with the square roots first. Okay, so first times first gives you, it gives you A because it's square root of A squared, which is just A. Okay, outside times outside. Minus square root of AB. Okay, inside times inside. Plus the square root of AB. Okay, last times last. Minus B. Square root of B times square root of B is just B. Alright, now what happens? Middle 2 cancel and we get A minus B.
Whoa. Oh, yeah, I saw it too, but that one's canceled out already.
So, it got much more simple. Do it? Yep, that's the answer.
I like canceling stuff out, it's so easy.
Okay, so the next one, everybody ready for the next one? Next one doesn't have any square roots, it's just regular numbers. Okay, so first times first. A squared. Outside times outside. Negative AB. Inside times inside. Positive AB. And last times last. What happens now? Cancel. A squared minus B squared.
I like how the answer was right before it.
Yes, the answers are right below it. So we can use this to help us in any problems, okay? Really, the one that you're probably going to use the most is the second one that we did because anything can fit in there. It's not restricted to square roots. Okay, so anytime you have conjugates multiplied together, you'll get a squared minus b squared. That's all you'll have left. Okay, so like for example, so example 5 down there. This is set up as a plus b, parentheses aren't very good, and times a minus b. So our answer should be a squared minus b squared. Okay, well, what is a squared? 2 squared, right? So it's 4. Okay, what's b squared? Square root of 3 squared, which is just 3. So our answer will be 4 minus 3, which is 1. So I took A right here, put it there. Took B right here, put it there. We squared them and we got answers and stuck it back up here.
What if you were to use the negative 3, would it matter? Negative square root of 3?
No, because when you square it, it would end up being positive again, so.
So does that only work when it's the same numbers?
Yeah, it has to be conjugates. Has to be conjugates. Okay, so you're gonna have to like recognize that. Be like, oh, it's conjugates, this is easy. Other than that, you gotta foil it like we did on the end of the front. Okay? So this is especially useful when we have radicals in the denominator and we have to get rid of them, right? So we have to rationalize. Sorry, that was a lot longer since I thought it was. So rationalize the denominator. Use the conjugate. Conjugate. When the denominator is a binomial radical. I don't know what happened there. I'm sorry. That's impressive. Okay, so we multiplied, remember last homework, we multiplied denominator over denominator, right? We have to multiply it by 1, but instead of denominator, we're going to say denominator's conjugate. So what is that this time? 1 plus square root of 5. So you have to do that to the top and the bottom in order to keep it the same value. Which means, probably want parentheses here. So the bottom, we're multiplying conjugates, right? So for the bottom, we can do a squared minus b squared. Well, what is a? 1, and 1 squared is 1. Okay, what is b? Square root of 5, okay. Times square root of 5 is just 5. So we get 1 minus 5 on the bottom. Now the top, I need to make my line longer because we have to FOIL it. Because they are not conjugates. Okay, so first times first, 3 times 1 is 3. Outside times outside is 3 square root of 5. Inside times inside, just square root of 5. All right, Lindsay. Last times last, it gives you just 5 when they multiply together. Okay. So, whoa. I didn't tell it to do that, I just did it.
Does it really matter, like, if you do it foil? Like, what if you went look foil?
It'd still work. Yeah. Okay, so on top, what do you get? 4 square root of 5. Because you had 3 plus 1 more right there. And then on bottom, we got -4. But here, we can cancel our 4s. So to make this a little easier, I'm going to write them as 2 separate fractions. Because you can do that. Just to make sure that everything gets canceled. Okay, so the 8 over -4 becomes -2. And then those become -1.
Negative square root.
Yeah, so you get -2 minus square root of 5. That's the answer. Any questions? Was it okay?
Wait, oh, wait,